All right, 8.6, we're going to learn about probability, which probability is the likelihood of an event happening. So the probability of an event, we would take the number of E, which is like the event, over the number of the sample size, which is the total. So in other words, it's what we want divided by the total. So I think this is the best way to think about it. What your goal is, what you want over the total. Probability can be expressed as a simplified fraction, decimal, or percent. So keyword here is simplified fraction. If you leave your probability as a fraction, make sure it is simplified. But all three of these would work as a correct answer. So I think in WebAssign, unless it specifically says like as a decimal or as a percent, you can leave it as either one of these. Another thing to know when finding the probability, if we see the word and, that means we're going to multiply. If we see the word or, that means that we add. So for example 2a, 2 coins are tossed. What's the probability that both land heads up? So I would flip one coin, I want it to be heads, and then flip another coin, and I want that heads to be that to be heads as well. So what's the total amount of outcomes that I have when I flip a coin? 2. It could be heads or tails. So the total would be 2.
But is that 2 coins?
2 coins, right? So I have 2 coins. The total would be 2 for each coin. And then I want it to be heads, so out of the 2, how many is that? 1. Am I flipping one coin and another one, or am I flipping one coin or another one? And, so I would multiply these. So this would be 1/2 times 1/2, which is 1/4. So as a simplified fraction, we could leave it like this, or we could say 0.25, or we could say 25%. All right, for B. A card is drawn at random from a standard deck of playing cards. What is the probability that it is an ace? So how many cards total do I have? 52. So that's why I put a deck of cards on Canvas so you guys can familiarize yourselves with a deck of cards. Out of the 52 cards, how many aces do you have in a deck? 4. You have one of each suit.
Are we going to be given that? Like,
No.
I don't know if there's going to be questions on cards, but do we like memorize? There's this many aces and this many.
There's 4 of each cards.
And how many different cards are there?
52 total.
So if it's
Right, we have to simplify this because it has to be a simplified fraction. So how would I simplify this fraction? 1/13. And then as a decimal, what would this be? 0.06, what? Or 0.07? So if I was leaving 4 decimal places, what would it be? 0.0769. So then as a percent, that would be 7.69%.
do you have to put it in all 3 forms?
It depends on what the question asks. So remember, the percentage, you just move the decimal twice. All right, so the numbers of colleges and universities in various regions of the United States in 2008 are shown in the figure. One institution is selected at random. What is the probability that that institution is in one of the 3 southern regions? What are my 3 southern regions? All the ones that say south. So west, south, central, east, south, central, and south Atlantic. So remember, when finding the probability, it's what I want divided by the total. So what is it that I want? The 3 south regions. So that would be these 3 added together. So 406 plus 286 plus 754. And then what is my total? Yes. So the total is all of these added together, which is 4,347. What do we get when we add 406 plus 286 plus 554? So 1446 divided by 4,347. 0.332 what? 0.3326. So then as a percent, this would be 33.26%. So remember, all three of these would work as your answer. Just make sure that this fraction is simplified. So if you're not sure if I can simplify either of those numbers, just divide it and your answer is the decimal. All right, next, yes. We have mutually exclusive events. So if A and B are events in the same sample space, then the probability of A or B occurring is given by this. So the first formula we have is if the events are overlapping. And then the second formula is if they are mutually exclusive, meaning that they have nothing to do with each other.
Will they tell you it?
No, they will not tell you.
So the mutually exclusive event be like, what are the odds of like this horse winning a horse race and like landing 6 on the 6 out of
Could be. So the next two examples I'll give you will be examples of each. So for example 5, one card is selected at random from a standard deck of 52 playing cards. What is the probability that the card is either a heart or a face card? So we're finding the probability of it being a heart and the probability of it being a face card.
And why can't we just use the other formula?
So it says or, so what am I going to do to these two numbers? I'm going to add them. So how many cards total do I have? 52. And how many of those are hearts? 13. There's 13 of each suit. So if I have 52 cards, there's 13 hearts, 13 diamonds, 13 clovers, I guess, and 13 spades. How many face cards do I have? What's a face card?
King, Queen, Jack.
King, Queen, or Jack. So King, Queen, or Jack, King, Queen, or Jack, King, Queen, or Jack. I have 3 of each suit, so how many face cards total do I have? 12. Do any of these cards overlap? Do I have hearts that are also face cards? Yeah. From here, I have how many hearts that are face cards, or how many face cards that are hearts? 3. So I have to subtract the overlapping ones. So because these two are not mutually exclusive, we have to subtract the ones that overlap. So when we add fractions, we just add the tops together. So this would be 22 over 52. Can I simplify this? Yes.
And why are you only subtracting by 3? Because then you can have 3 of each one. Oh, because it's
So when we simplify, we get 11 over 26. 0.423, or as a percent, 42.3%. All right, I'm going to do another example at the bottom here. So let's say, what's the probability of it being a 3 or a face card? How many 3s do I have in the deck? 4. So 4 out of 52. Or means that I do what? Add. And how many face cards do I have in the deck? 12. Are any face cards going to be the number 3? No. None of these overlap. So all I do is add these two together. So this would be 16 over 52, which would simplify to what? 4 over 13. Right, for example 6, the Human Resources Department of a company has compiled data on the numbers of employees who have been with the company for various periods of time. The results are shown in the table. So an employee was chosen at random. What's the probability that the employee has 4 or fewer years of service? So remember, it's what we want over the total. So how would I find the total? Add up all of these together. So we would get 529. And then what is it that we want? So 4 fewer years would be 157. What's 157 divided by 529? 0.2968, or we could say 29.68%. All right, for B, now I'm looking at 9 or fewer years of service. So how would I find the amount of people that have 9 or fewer years of service? Perfect. So we're looking at 9 or fewer, which would be both of these added together. So that is 157 plus 89. What would that be? 246 divided by 529. And what do we get? What is it? So 0.465 or 46.5%. All right, so in dealing with marbles especially, we can have with replacement or without replacement. So if I was choosing a marble from a bag, I can either put that marble back in the bag, so that would be replacing it with replacement, or I would take that marble out and just put it on the table and not put it back in the bag. So let's say I had 10 marbles to start and it was without replacement. If I picked one out of the bag, I have 10 total. But then if I picked a second marble out, how many total do I have now?
11.
If I took one out of the bag?
9.
9. So it'd be one less. So looking at example 1, so 8 marbles in a bag, 4 red, 2 green, 1 yellow, and 1 black. Without replacement, what's the probability that I pick 1 red and 1 yellow? So if I pick 1 red, how many red do I have? 4. And how many marbles total are there? 8. 8 marbles in a bag. Now it says without replacement. So I pick a marble out of the bag and put it on the table. So now how many marbles do I have in the bag? 7. I have 1 less because I didn't replace that red one that I just picked out. How many yellow do I have in the bag? 1. And when this says and, what do I do with these two numbers? Multiply. So when you multiply fractions, we multiply straight across. So 4 over 56, which would be 1 over 14.
Is this kind of what we were doing on 8.5? Like,
All right, for the second one here, what's the probability that we have 1 black or 1 red? So how many marbles total do I have? 8. And how many black? And if this says or, what am I going to do? Add. So it's, again, without replacement. So I just picked the black one out and put it on the table. Now how many marbles do I have in the bag? I have 7. And how many of those are red? 4. How do I add fractions? What do I need? Common denominator. So I'm going to multiply the top and the bottom of the first one by 7. So I get, because it's without replacement. So in the second time I draw a marble out of the bag, I only have 7 marbles total now. And then this fraction would become 32 over 56, because I multiply the top and bottom by 8. So this would be 39 over 56.
Wait, why are we adding these what we multiplied by first?
Or,
Got it.
example 2. So I have 8 marbles in a bag, 4 red, 2 green, 1 yellow, and 1 black with replacement. What's the probability that I pick 1 red and 1 green? So now I'm picking a marble out and putting it back in the bag. So the number of total doesn't change. How many red marbles do I have total? 4. And what's the total amount of marbles? 8. Yeah. Remember when I said take a picture because this was added? And then how many green marbles do I have? 2. And how many marbles total do I still have? 8. And if this says and, what do I do to these two numbers? Multiply. So 4 times 2 is 8. 8 times 8, 64. So would this simplify to? 1 over 8. 1 over 8. Yes. Go ahead. All right. All right, so the last one, what's the probability that we pick a green marble? 2 over 8, perfect, because we have 2 green marbles and 8 total. So again, with replacement, I'm putting it back in the bag. What's the probability that I pick a red one? 4 over 8. And if this says or, what do I do to these two numbers? Add. So this would be 6 over 8, which is 3 over 4.